Alright, we're going to conclude the longest lesson ever, lesson 10.2, talking about polar graphs, with the last two examples which focus in on some of the calculus that you can actually do now with polar curves. So, number 15 here says find an equation of a tangent line to the graph of r equals to 2 times 1 minus sine theta at the point 2 comma 0. Interesting. Okay. We've seen stuff like this before. Tangent line equation. Oh yeah, we need a point and a slope. Well, we got a point. That's great. By the way, this point here is actually x and y. So x and y value, good. And we then need to know the slope. Right. So the slope, I'm just going to do up here, is what? Oh yeah, dy dx. So how in the world do we calculate dy dx in polar? Well, I'm going to link this back to what you did in the lesson 10.1, where we learned about parametrics. And what was the dy dx formula for parametrics? Oh yeah, that was just dy dt all over dx dt. Well, how can I extend this now to polar? Well, remember in parametric, the independent variable was t. What's my independent variable here in polar? It's just theta, right? So I can just change the t to theta. So dy d theta all over dx d theta is how I calculate the slope using polar coordinates. Okay, so let's go ahead and do that. So find an equation tangent line. Well, you're like, let's find dy d theta and let's find dx d theta. Well, how do we find this? I guess we need to find y first. And how do I find y? Well, remember y is just r sine theta. Yeah. And then here I told you that r is equal to this, so we got to stick that into r. So our equation for y is actually 2. And I'm going to actually multiply this in so I don't have to have that many brackets. 2 minus 2 sine theta times sine theta. Okay, that's y. So I need to find dy d theta. Let's take the derivative. Yeah, so dy d theta is, oh, look at this. I see one thing times something else. Can you sing a song for me? That's right. Product rule, a prime b plus b prime a. So let's do this. A prime, so the derivative of 2 is 0. The derivative of 2 sine theta is 2 cos theta. Right? A prime b, which is just sine theta, plus b prime a. So b prime is cosine theta, right? Times a, 2 minus 2 sine theta. And if I were to simplify this, what do I have here? Negative 2 cos theta sine theta plus 2 cos theta minus 2 sine theta cos theta. I think I actually get this. I get negative 4 cosine theta sine theta plus 2 cos theta. That is my dy d theta. Awesome. Okay. Now I guess I need to find what? Yeah, the same thing for x. So I'll use a different color for x. X equals to r cosine theta. So once again, x equals to r, which is 2 minus 2 sine theta times cosine theta. Once again, a prime b plus b prime a. A prime b plus b prime, which is negative sine theta. A, which is 2 minus 2 sine theta. I should simplify this, shouldn't I? Okay, negative 2 cosine squared theta minus 2 sine theta plus 2 sine squared theta. Don't really know how that helped, but whatever. That's okay. All right, so now we have to evaluate. So what is dy dx? It's that dy d theta over dx d theta, and then we need to evaluate it at some sort of theta. Well, remember, This is the coordinate 2 comma 0. What is the angle theta that gives me this coordinate of 2 comma 0? Gotta think back to what theta would be if I thought theta was 0. What sine of 0? Sine of 0 is 0. 1 minus 0 is 1. Oh, yes. So this actually corresponds to the theta value being equal to 0. So now I can say to you, let's find the slope at theta equals to 0. And I'm going to now plug in the dy d theta on top, negative 4 cos 0 sine 0 plus 2 cos 0. And I'm going to plug in the bottom, negative 2 cosine squared 0 minus 2 sine 0 plus 2 sine 0 all squared. And we're going to evaluate. So let's evaluate. Uh-oh, my pen is running low. Hopefully you can evaluate. Let's evaluate. I think I get what on the top? 0, 0, cosine 0 is 1, so I get 2 on the top. And then 0, 0, and I think, oh no, cosine 0 is 1, so negative 2 on the bottom. Oh, look at this. My slope value is negative 1. Wow. Okay. And therefore now I can find the equation of the tangent line. I'll just use the point slope form. Y minus y sub 1 equals m, which is negative 1, bracket x minus x sub 1, or even y equals to negative x plus 2. There you go. Okay? So that's how you can do a question like this. Remember here, you need to find dy and its d theta, right? So theta is the independent variable, and dx d theta, you can figure that out by just, once again, plugging in x equals r cos theta and doing the derivative using product rule. Okay. Now I've seen some textbooks actually give a formula for this dy d theta over dx d theta. Okay. And let me just take a few moments to show you that right now. You don't have to do this if you don't want to, but sometimes I've just seen it in a book because I'll say up here, I know, kind of messy, but sorry. I'll say, how can you figure out this stuff? So remember how I said y equals to r sine theta? Well, if I want to find dy d theta, yes, I just use product rule. So the derivative of r is r prime, or I'll just use dr d theta because r is a function of theta. So a prime b plus b prime, which is cosine theta, times a, right? So there's our x, or sorry, there's your dy d theta. Okay. I can do this something similar with x. So x equals to r cosine theta. So same idea, dx d theta, dr d theta times cosine theta plus, oh, negative sine theta times r. Okay. And so that's why a lot of times you'll see this in the textbook. So once again, I'm going to use this. I'm going to say dy d theta all over dx d theta is given by this formula. So I'm going to copy this down. dr d theta sine theta plus, I'm going to move the r in front, r cos theta all over, and then it's dr d theta cos theta minus r sine theta. So you see how these things are reversed, right? Cosine, sine, sine, cosine. And so in some textbooks, they say that the derivative of y with respect to x is this formula here. Now, it's up to you if you want to memorize that and use it. You can if you want, or just go back to the basic principles like what I did earlier in the black here and just use product rule as well to figure out the derivatives. It's up to you, okay? And we'll finish off this video with this last example, number 16, where now I'm saying, can you find the points at which the graph of r equals to 2 minus 2 cos theta has horizontal tangents? Okay, so if you want to have some practice right now, you can go ahead and try to graph this out. If you don't, then I'll just quickly do it for you here. I'll tell you this is the one that looks like a heart, a cardioid, so I think it looks like this. I think it goes up to number 4, and then going back like this. This is it close to Valentine's Day yet? You can draw these for your Valentine. Yeah. Oh, wouldn't your Valentine love drawing these? Okay. So it looks like there are two particular points where there are horizontal tangents, right? And there actually, I think, looks like, I don't know, maybe three different points for vertical tangents. I'm looking at horizontal ones here, right? Here. Vertical ones, vertical ones perhaps here, I don't know, perhaps here and here. So that's kind of interesting. But remember how we find horizontal tangents? Tangents, of course, means slope, so a horizontal tangent means that the slope equals to 0. And for a vertical tangent, it's an undefined slope, so this is where the denominator equals to 0. So remember how we figure out slope using polar? dy dx is equal to dy d theta all over dx d theta. So really, if I want to find the horizontal tangents, I need the numerator to be equal to 0. And, yeah, you guessed it, I need the denominator to be equal to 0 for vertical tangents. All right, so that's what you need to do. You need to find dy d theta set equals 0, solve. You do that with dx d theta set equals 0 and solve. All right, so I've told you the game plan. Now let's see if you can execute the actual calculations. All right. So if you want to challenge yourself, I'd press pause and do it yourself. Otherwise, uh, wait for me. Okay, here we go. Which one do I do first? How about the horizontal tangents? Yeah? Sure, that means I need to find dy d theta, which, oh, I should actually use y first of all, right? Scratch that out. Y, what's y? Y is r, which is 2 minus 2 cosine theta. Sine theta. Here we go. dy. Well, you know what? Before here we go, if you don't like using product rule, guess what? You could actually just do this by distributing. But I know you love product rule, right? You love singing the song. Here we go. A prime. So the derivative of negative 2 cosine theta is 2 sine theta. A prime b plus b prime a. 2 sine squared theta plus 2 cosine theta minus 2 cosine squared theta. Good. And I need to solve this. Set this equal to 0 and solve. Uh-oh. Don't like it when I have two things or two trig functions, cosine and sine. Oh, this is your pre-calculus knowledge. That's where it comes into play. Sine squared is 1 minus cosine squared. Right on. Right on. That's where you learned all that stuff from pre-calculus 12. 2 minus 2 cosine squared. 2 cosine squared minus 2 cosine squared. Ooh, I have here, what, negative 4 cosine squared theta plus 2 cosine theta plus 2. Let's factor out a negative 2. 2 cosine squared theta minus cosine theta minus 1. Nice. I can factor that to solve all this stuff from pre-calculus 12. Wow. I think it's just 2 cos theta, was it plus 1? Yeah, and then cosine theta minus 1. Nice. So therefore, what do we have here? Oh, let's solve. So I guess here, 2 cosine theta plus 1 equals 0. Cosine theta equals to negative half. Oh, I'm going to solve that. So theta equals to the inverse cos of negative half. What is that going to be? Half. That's pi over, pi over 3 is the reference angle. This is where cosine is negative, so I'm thinking quadrants 2 and 3. See all this stuff, the trig stuff you are supposed to learn in pre-calculus? Coming back to bite you. 2 pi over 3, that's one answer in quadrant 2. The other one in quadrant 3, I think, would be then 4 pi over 3. Good. And then this other one here, if I were to solve that, cosine theta equals to 1, so theta equals to 0. Got that. Now, let's just double check if this makes sense. 2 pi over 3. If I were to draw this angle 2 pi over 3, yeah, I guess that's okay, yeah. And then 4 pi over 3, probably though there, yeah, I think that's okay too. I think you actually do get the horizontal tangents. I didn't draw the graph very well. I think it should have been like this, yeah. Okay, now what about this one at 0? That's kind of interesting. Theta equals 0, so I guess if you were to enlarge the heart, right, you could potentially say that there is a horizontal tangent at 0. Actually, you don't think you can. It's a cusp, so that actually is an extraneous root. Don't include that, okay? So you actually have two values here where you have horizontal tangents. Let's actually find the coordinates. So I need to now actually find the r value for both of these. And you can just do that by quickly plugging it back into the original equation. Cosine of 2 pi over 3. What is that? Oh, that's just negative 1/2. Negative 1/2 times negative 2 is positive 1. 2 plus 1 is 3. Oh, nice. It's just 3. So both of them, I think, are 3. Okay? Those are your 2 points. And these are, once again, in r and theta form. Cool? Horizontal tangents at these 2 points. Sweet. Vertical tangents. Oh, vertical tangents. That's dx dt. Sorry, dx d theta. So x equals to r cosine theta. This time I'm actually going to not use product rule because I just want to do something different. I'm going to actually distribute this. So we have here 2 cos theta minus 2 cos squared theta. And then now I can take the derivative nicely. The derivative of 2 cos is negative 2 sine. Minus 2 is a constant. Ooh, the derivative of cosine squared. Oh, bring the 2 down. Oh, did you think? Oh, chain rule. You got it. The derivative of the inside function of cosine is negative sine. So if you were to simplify this, negative 2 sine theta plus what? 4 sine theta cos theta. And if I were to solve it, I will factor. Let's factor out 2 sine theta this time. Negative 1 plus 2 cosine theta. And of course, this has to equal to 0 for the vertical tangents. So sine theta equals to 0. That, of course, means 0, pi, 2 pi, and so on. And then over here, 2 cosine theta equals to 1. Oh, cosine theta is 1/2. And if I solve here, I get all the answers of what? Pi over 3, I think it is. What else? Oh, yeah, 5 pi over 3, and so on. And so I would plug in these values in. Let me look at pi over 3. I think that will just give me the r value of 1. 5 pi over 3 is also the same y value of 1. Not y, yeah, y value or r value of 1. And then I'm thinking 0 doesn't make sense, but pi sure does. 2 pi does not. And so if I put in pi, plug it back into the original function. What's my original function again? Yeah, right there. R equals to 2 minus 2 cos theta. I'll plug in cosine of pi, that's negative 1, so 2 plus 2 is 4. Okay, so once again, r theta, these points, 1, 2, 3, vertical tangents. Wow. Whew. Crazy, crazy, crazy. You see how we're trying to now mix everything you've learned in the past to put it together in this complicated multi-step problem involving polar graphs. Wow. Spend some time working on this, okay? I know this is hard, this is crazy, this is weird. Gotta spend some time, just work at it, plug at it, try it, ask some questions, okay? If you're not too sure, please ask, okay? Start doing your assignment now.